No, I'm just giving you a verbal confirm. Okay.
I'm saying yes.
TikTok. You're live on YouTube.
Right.
TikTok.
Yay.
There you go. I'm going to cut this into a little promo and great show.
All right. All right, everybody. All right, welcome to Math Thursday, where we are going to do, I don't know how many problems we're going to get through today. Let's just see how many we get to. All right, so let's start out with this one right here. So these problems are all going to be from a practice ACT exam, so buckle up. And of course, as usual, if you guys can't hear me or you can't see it, pop it in the chat and we'll take care of it. But go ahead and figure out your answer and put it in the chat. Let's get into it. All right, we've got our first guess in, or answer in, I guess. And we got 2 people for A's.
Turn the change the noise setting.
What? Oh. Ooh, Joel, you're saying no solution. Interesting. All right, hi from It's Texas. Hi, I grew up in Texas. Thank you. All right, Mick Swagger over on YouTube is saying it's B. Paul, you know me. Interesting. Okay, we've got a lot of A's and B's. So like I said, for those of you who are just joining us, this is from a released or a practice ACT exam. And so when we're looking at these, that's what we're going through. And so what I like to do is I don't work these out ahead of time or anything like that. So we're going to be working them out together in real time, and we're going to figure out what the answer is together. So you're going to see how I work these out. Okay. Mia, would you have to do property? So the only thing you really need to do in this one is substitution. So the substitution property would be the only property that you really need to do with this. All right, I'll give you guys another minute or two. Yeah, make sure you share the live, all of that fun stuff. You know, let's get some likes and all that sort of stuff going on in the feed. Help us keep this going. Hey, Math Joy. All right, so it's Texas over on YouTube. You're saying E. Got lots of people saying A and B. All right, let's go ahead and get into it. Okay. So we've got given x equals 5, y equals 3, and z equals -6. We've got what is x plus y minus z times y plus z. So what I'm going to do first with this is I am going to substitute in all the values that I know. So x is 5, y is 3, and z is -6. So what I'm going to do is I'm going to take this here, and I'm going to make all of my substitutions. I'm just going to move it over here so I have enough room. Okay, so x is 5 plus y, which is 3, minus z, which is -6, times y is 3, and z is -6. Okay, so 5 plus 3 is 8. 8 minus -6 is the same thing as 8 plus 6. So that's going to be 14. And then 3 plus -6 is going to be -3. So if I have two numbers that I'm multiplying together, I just multiply the numbers together. However I want to do that, if I want to use a calculator or whatever. But since they have different signs, so one's positive, one's negative, that means that my answer is going to be negative. And that is going to be -42. So the answer to this is A. Yay. Okay. Yeah, so minus and negative is going to be the same thing as making it positive. So making it less negative makes it more positive, if that makes sense. Okay. All right. Okay. Ooh, let's check this out. Okay. So Mia, if you take a look, at this, you can probably still see it, but you're really just substituting in those X, Y, and Z values and then just going through order of operations. Hey, it's Texas. You're 12. You're trying. That's totally fine. You're doing great. I'm glad you're here. Okay, so this is getting into a probability question here. Okay. Oh yeah, and then I forget that ACT does the A, B, C, D, E, F, G, H, J, K. Some standardized tests will do that, which can get really confusing. Math joy. I love math. I also hate math. It's the food. We have our preferences. I mean, there are parts of math that, I mean, overall, I would say that I love math, but man, I've made no secret of this, but I really struggled in math when I was in school. which is why I think I became a math teacher, or because I've liked being a math teacher and being like, I'm pretty patient for a math teacher, and I don't mind explaining things in multiple ways because I needed to think of things in a different way. So yeah, I get it. It's a love-hate relationship for a lot of people. Okay. So Bailey, we're going to get into some of the details of how we would do this, right? Okay. Let me give you guys another minute or so to get this one. Okay, so let's see. So we've got this pre-prom dinner that must choose one item from each of the 3 categories. So you have an entree, a side dish, and a beverage. So you've got 3 different things that you have to choose, right? So let's think of this a little bit simpler. So first, let's talk about if I have let's say I have the flavor of ice cream, which is, it's going to be A or B. Well, we can do chocolate or vanilla. Okay, so we've got chocolate or vanilla ice cream. So if that's it, if I can just pick chocolate or vanilla ice cream, I've got 2 choices, right? Now, if I start adding in toppings, right? Let's say I could get chocolate or vanilla, and then for toppings, I could get none, or I could get sprinkles, or I could get caramel sauce. Okay? So if I choose chocolate, so that's my first thing is chocolate. Now I could get chocolate with no toppings. That's one choice. I could get chocolate with sprinkles. Here, wait, let me draw this out. So I could, if I choose chocolate, I could get chocolate with no toppings, chocolate with sprinkles, or chocolate with caramel sauce. So that's 3 choices. But then I could also choose vanilla. And if I get vanilla, then I could get it with nothing, or with sprinkles, or with caramel sauce. So that right there is 6 possible outcomes, right? Because I've got 2 choices for this level, and then I've got 3 choices for this level. So what I do is I just look at how many different choices do I have for each category or each kind of level of choice that I'm making, and I multiply them together. This is called the fundamental counting principle, okay? So using that idea, if we go back to this problem, so we've got an entree, we have a side dish, and we have a beverage. Okay, now they have 3 entree choices, they have 4 side dish choices, and 2 beverage choices. So if we think about all the different pathways, right? If I choose this first entree, so I could have this side dish, or this side dish, or this side dish, or this side dish. And then whichever one I pick, it's either going to be here, or 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 here, right? It gets to be a mess really quickly if you're trying to draw it out, right? So what I'm going to do is I'm actually just going to, because it's not asking me what are the different combinations, it's just asking me how many are there, right? So it's going to be, there's 3, there's 4, and there's 2. So 3 times 4 is 12, 12 times 2 is 24. So there's 24 choices there. Okay. All right, so again, If you're just joining us, these are like released ACT questions, and we're just working through them. So go ahead and tune in. These are nice to kind of flip through and just try them out. Okay, we got another probability. Okay, so Bailey, I'm going to kind of zoom out on it a little bit. I know sometimes the banner is kind of high. All right, so take a look at this probability question. Okay, we got this bag of marbles. Again, standardized tests love doing questions with bags of marbles. It's B's and B's. Okay. So Talia on YouTube says prerequisite is basic probability knowledge to solve this. Yes, so this one, so the ACT and the SAT are sort of like standardized placement exams that most students in the United States take before they go to college. So the vast majority of the content on these exams is like pre-algebra, algebra 1, geometry, like kind of early high school. So most of the questions that you come across on the ACT and SAT are algebra 1 and geometry or lower. Every once in a while, there's some questions that go into like pre-calc or algebra 2. But the last question and this question that we did are both just kind of basic probability things. Okay, so basic probability. This is, basic probability is given to you as a fraction, right? So on the bottom is always the total number of possible outcomes. Total number of possible outcomes. Okay, so how many possible things could happen, right? And the top is the number of ways that you could, we say number of favorable outcomes. Okay, so this is the number of favorable or desired, like what you're kind of paying attention to. Okay, so that's basic probability fraction ratio type of thing, right? So the total number of possible outcomes, they give it to you right here. You have 13 marbles that you could pick from, right? So 13 is going to be on the bottom. Okay, I've got 13 solid colored marbles. If I'm reaching in to grab one, right, there's 13 possible marbles that I could grab. Okay, so now the number of favorable, or like the ones that we're looking for, right, the ones that we're paying attention to, right? So any marble that is not black in color, so that gives us 3 red, 5 white, and 1 yellow. So 3 plus 5 plus 1 is 9. So our answer here is D, because there are 9 marbles which are not black in color, and there are 13 possible marbles that we could have picked. There we go. Okay. So that's what we're looking at, is these are the number of ways that we can get our desired outcome. And these are the total number of possible outcomes, right? There's 13 possible marbles in there. Okay, so those are the first 3 problems. So let's look at this one. Okay, let me move this down because I know you, there we go. Okay, thank you, Tala. Tala or Talia? I can't really see, sorry. Rick, it's always an interesting day when the kids become smarter than us. But you're in the right place. You are in the right place. I'm here to help the helpers. Yeah, I've got a 12-year-old. I mean, she thinks she's outsmarting me all the time, but I know. I got her. All right, guys, take a look at this one. Let's see what you've got. Go ahead and put your answer in the comments. Ooh, and the next one after this is going to be some geometry. So again, these are from released ACT questions. I don't know how old this one is, but they really don't change that much, honestly. I mean, the math doesn't really change. Yeah, I don't think the ACT and the SAT like question style hasn't really changed that much in many years. So, you know, practice is practice, right? And that is a big way to, if you're looking to get your math choice. Oh, thanks, Talia. Yeah, if you're looking to improve your like test taking scores, you've got to take tests. You've got to do practice. So that's kind of the best way to, and it's not just necessarily understanding the content, although that is obviously kind of helpful to understand the content. But it is also to get used to the format of the questions themselves, because oftentimes there's a pattern that starts to emerge from all the tests, right? And now that the SAT is digital primarily, you know, it can change. It's a dynamic test, all of that. ACT you can still take on paper, which is kind of nice, that you can go back and check and all of that kind of things. All right, Bailey, you don't know? Try something. All right, let's lock in our last answers before we start getting into it. But not Diane. You know it, but you feel like there's an easier way to do it. Maybe, but you know what? That's the big secret of, like, nobody's checking your work. It's okay. Okay, so let's get into this one. All right, because I really like this question because it demonstrates my 2 biggest test taking strategies. Okay. That'll get you through pretty much any standardized test. There are the vast majority of questions on standardized tests can kind of be solved in 2 different ways. Now, there are outliers. I get it. There are some questions that don't fit into this, whatever. But especially with the multiple choice question, okay? So you're either going to need to set up an equation and solve it and figure out what the answer is and then find your answer out of the choices. or use the answer choices to then figure out which one is the right one. So this one, you could solve both ways, but like when you start looking at it and you go, I'm not even sure where to start, right? I'm not even sure where to start. So what you can do is, if you're not sure where to start, see if you can work backwards. See if you can take some of those choices, because out of these 5 values, you know one of them is correct, right? You know one of them is right. So why not just start plugging them in, right? So if he worked 48 hours, okay? If he worked 48 hours, then that would mean that he got $12 per hour for the first 40 hours. So he's going to get 40 times 12. And then he worked 8 more hours over 40. And he's going to get $18, $18 for those 8 extra hours that he worked. Okay? So now 40 times 12 and 18 times 8. Ugh. Can get my calculator. Okay, 40 times 12 is 480. And 18 times 8 is 144. So if I add those together, I get 624. So that's a little too high, right? That's about $54 too high. So we know that it's not 48. So now if I jump back down to 32, well, 32, I'm looking at 32 hours now. That means he only earns $12 per hour, right? So 32 times 12, 32 times 12 gives me 384. That's way too low, right? So now it's going to be somewhere in the middle. So now I'm just going to jump up and I'm going to try 38. So again, 38, he's still only making $12 an hour, right? 38 times 12 is 456. Okay, whoops, 456. All right, so then let's try 45. So 45, again, we're going to have 40 times 12 plus 5 times 18. Okay, so 40 times 12 plus 5 times 18 is 570. So there we go. My answer is J. It was 45 hours. I didn't have to really set up the equation or anything like that. I'm just going to use those answers that they give me because they already narrowed it down. And I'm going to just start putting it in, right? Okay. Oh, Sydney, so you're starting algebra, but I want to also do geometry to catch up. What do they usually do? So, Sydney, typically in school, you're doing algebra and then geometry. So, or you're doing algebra with some geometry mixed in. But you're actually in luck because we are going to do a geometry question next. Anna is asking, how often do you do these live? So we are live every Thursday at 8 o'clock, usually from 8 to 9. From 8 to 9, I guess Eastern. Yeah, we're Eastern, yes. Okay. And once we get into like the school year, I'm usually not doing like the ACT and SAT questions. I'm usually doing more of like, ask me anything. So if there's anything that you want me to go over, things like that. I'm currently studying linear algebra. Isn't that just y equals mx plus b? No, linear algebra, when you're talking about algebra with a linear equation, y equals mx plus b, yes. But linear algebra is mostly, it's a lot more than just that. It gets really complicated. All right, so Hungry Man, you think if I'm an AP Calc junior year, I'll be good on the math? I mean, it depends on where you are right now. Depends on what you're doing right now. You know, AP Calc junior year is pretty accelerated. So as long as you have a really solid algebra foundation, you know, go for it, but don't rush it. It's okay. You're gonna be fine. Okay. All right, guys, so we've got a geometry question now. Let me know if you need me to move it up or down or zoom in or whatever. Maybe zoom in a little bit closer so we can see, so you can see the diagram a bit better. There we go. Oh, we got some good conversations going on in the chat. So Tali on YouTube is asking if it's a good approach to learn specific maths concepts for a specific purpose to solve problems in professional jobs or career. I think, you know, you never know what your job or your career is going to be. And so my recommendation is to learn as much as you can because you never know. So case in point, my mom, both of my parents have, you know, they were theater kids. They were masters of fine arts. And, you know, my mom was going to be an actress on the stage for a long time. And she was when I was a kid. And then she needed a career change. And so she went back to school and became a math teacher. And she was a 6th grade math teacher for 30 years. So you never really know what you're going to end up doing. I did not think I was going to be a math teacher my whole life. Apparently some people in my life did know that I was going to be a teacher, but I didn't realize it. But you know, it's important to learn as much as you can because again, you never know what you're going to end up needing and using. Okay. All right. Ooh, good conversations. Yeah, and now I'm so happy to be a math teacher. I love it. It's my favorite thing. Yeah, so math joy. How about we learn math for enjoyment rather than some kind of usefulness? I mean, it can be both, right? It can be that you are enjoying it and it's also useful. I mean, I think that's math in a nutshell, is that it can be really enjoyable. It can be really tedious, but it can be really enjoyable, and it's always useful. Okay. All right. So there's some really good information in this description, right? So in the figure below, AB is congruent to BC and AE intersects BF at C. So AB is congruent to BC. So I'm going to go ahead and I'm going to mark that these two sides are congruent. Now, if those two sides are congruent, then what that means is that this angle and this angle are congruent also. Congruent is just like the geometric term for equal. Okay, when you're talking about like these parts are equal. Okay, these corresponding parts are congruent. Okay, so this triangle is a specific type of triangle, which is an isosceles triangle. Now, all angles in a triangle add up to 180. When this angle here is 26 degrees, that means that this angle here is also 26 degrees because they are vertical angles. Okay, so vertical angles is when they're like across from each other in an X, because it's the same no matter how you sort of like twist that around, right? So that's 26. So that means that this angle is 26. And since it's congruent with angle A is also 26. So then angle B that's here that we're trying to figure out, right? We've got, so 26 and 26, that's going to be 52. All right, so 52 plus angle B is going to equal 180. So again, the 52 came from 26 plus 26 from angles A and C. So angle B is going to equal 180 minus 52, which is 128. So the answer is D. So that was sort of, I would say that's like 3, maybe 4 key geometric concepts. So we've got vertical angles, which are the ones that are like across from each other in an X. We've got the fact that all 3 angles in a triangle add up to 180, right? We have we have an isosceles triangle, right? 3 and 4 are kind of mushed together, but that we have an isosceles triangle, and that if you've got 2 sides of a triangle that are congruent, then those angles that are across from there are also congruent. Okay. All right. Yes. So Mergy, I think that's your name, Mergy. Since the sides are equal to each other, the angles are also equal. Yes, exactly. So if the sides are congruent, then like the angles that are, so your angle determines the side length of the side like across from it. So if those 2 sides are congruent, then those 2 angles are also going to be congruent. Okay. All right, let's take a look at this one. Oh my gosh, let's do this actually. I think I want to do this one. Sorry guys, it keeps mushing around. Yes, so Sydney, yes, whatever, no matter what the triangle is, the angles will add up to 180. Okay. So, Sir Bear, there are 180 degrees in a triangle. Not true unless you specify it's a Euclidean surface. So in these types of exams, and at least in the courses that I teach, it's all Euclidean surfaces. So with all of these, and there's usually some sort of like statement at the beginning that says like you can assume that everything is coplanar and things like that. So you're not doing anything non-Euclidean. Oh, Mergy, yeah. I love doing that. You can absolutely just plug this into a calculator and find the answer. That's one of the beautiful things about these standardized tests, is that you can just plug it into the calculator. Okay. Now you guys know I prefer my NumWorks calculator, but you can use whatever calculator you want. If you're interested in this NumWorks calculator, there is a free emulator that you can download, an app. There's a free app so you can try it out. It's amazing. It's really amazing. Okay. Okay, so math, Joy. 360 degrees in a circle is just something made up by humans. It's not a math fact. True, I guess. But I mean, so is time, so is inches, so is miles, like any units, right? It's just a unit that works with all of these different things. Oh man, Sydney, what's Euclidean? That's a so Euclidean. So Euclid was a mathematician, ancient times. Ancient Greek or ancient Roman, I can't remember. Anyway, I mean, honestly, don't worry about it. Any geometry course you're going to take in high school, especially, is going to be based on Euclid's geometry. So that was geometry that's been around forever, right? Not really forever, but now we're getting to the good stuff. Okay. All right. So, well, I mean, math, Joy, there would be 360 degrees in a Martian circle if it was just humans on Mars. Oh, boom. Okay. Greek, father of geometry. Thank you. I couldn't remember that. Radians do make more sense than degrees. I'm with you on that one. Okay, so in scientific notation, what is the product of 3 and point blah, 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 7, 2? So as somebody pointed out earlier, this one on this specific question, I would just multiply this. I would put this right into my calculator and I would do 3 times 0.0000072. It's going to give you something along the lines of this. It's going to put out something like 2.16 e negative 6, okay? That e, whenever you see that, and a lot of times my students will see that after they're just like, you know, pushing a bunch of buttons all on their calculator over and over and over, and they're like, I got an error. And it's like, no, it's not actually an error. It's e, which really means times 10 to the something power. So e negative 6 is times 10 to the negative 6th power, excuse me. So my answer right here is B, 2.16 times 10 to the negative 6, done. And then you move on, okay? On these standardized tests. So again, this is one of those things where this is why we practice standardized testing and practice these things, because you learn the calculator keystrokes and things like that. All right, we've got one more page to work through. Looks like this one's got some function notation. I love function notation. Okay, so go ahead and pop this one into your into the chat. Yeah, Jill, you could just count the decimals. Yep, that's the 10 times negative 6. Yep, or times 10 to the negative 6. So, Margie, yeah, this is kind of getting into algebra 2 a little bit more. You're starting to see function notation a little bit earlier, which is nice, because once you get into like upper level math, that's all you really see. That, I mean, algebra 2 and most of a lot of pre-calc is just all functions. So yeah, so function notation, what it does is whatever is in these parentheses here is what goes here. Okay, so if it were, so this one's f of 1, so f of 1, I'm going to replace all of my x's with 1s. So it's 4 times 1 plus 3 squared. So 4 times 1 is 4, 4 plus 3 is 7. So this is 49. So that's K. Okay, so with that one, once you understand that whatever's in the parentheses goes in to or replaces the X, it's a lot easier. Like it's pretty straightforward with all of these questions. Mergy. Does ACT have Desmos or is it just ACT? Or just SAT? That's a really good question. So I know for sure that the SAT provides the calculator. Let me see. Yeah, it looks like there is. If you're taking it digital, yeah, the online ACT includes a Desmos graphing calculator, but you can still bring in your own calculator, whatever you're comfortable with. So for me, like having the actual calculator in your hand, the one that you've been using in math class and all of that, that sometimes to me is a little bit more of a comfort. But you can also use that Desmos. So if you're not sure about how to graph on your calculator, like Desmos can be used on the graphing and all of that. Okay. All right, let's do a couple more. Okay. Ooh, let's do these last two. All right, let's do this one. It's number 10. A little bit of multiplying polynomials. Okay. Sir Beaubear, it's not cheating, it's using your tools wisely. Ooh, okay, so Sydney Todd, it looks like you kind of added those together and they're not being added, they're being multiplied. Yeah, so they're being multiplied together. All right, so when we're multiplying things together, when we're multiplying these different polynomials together, these different binomials together, we want to make sure that everything gets multiplied by everything, okay? So 2x needs to be multiplied by 5x, and it needs to be multiplied by -6. And then the plus 3 needs to be multiplied by 5x and -6. Okay, so when I do 2x times 5x, that gives me 10x squared. Okay, so I can use FOIL method, yep. So I can use FOIL, yep. Okay, and then I do 2x times -6, that's going to be -12x. Okay, and then I have the plus 3 times 5x, which would be plus 15x. And then the plus 3 times -6, which is -18. And then I look to see if anything can be combined, and it can. So the only ones that I can combine is the -12x and the plus 15x, because they both just have they just have an x by itself without an exponent. So I have 10x squared plus 3x minus 18. So this is one of those that's a good example of like, you just kind of have to solve it and then find the right answer because starting out with these, it wouldn't really make any sense because I feel like you could justify a lot of these if you weren't quite sure about foiling those together. Okay, so 10x squared plus 3x minus 18. So we've got k right here. There we go. Okay. Oh, Beastas, why does this work? Where would you see this in business or in the world? I mean, yeah, so it can be engineering or banking or anything like that. But there's also things like if you were like, I mean, one thing that I can think of is just like organizing, making sure that everything gets paired up in the right way. So like reorganizing a closet, like it's the same sort of idea, which is organizing and combining things that go together. But also even like divvying up things in a classroom or for like a class set of something and making sure that each student is going to get the same thing or the same number of things, make sure that everybody gets something into their own little bucket and things like that. Okay. So even if you're not going into a lot of math, is all with problem solving, right? So problem solving, organization, like organizing these things through. This is so much of just organizing and making sure that everything gets multiplied by everything else. At its core, in the simplest way possible, that's where it is, right? So you may never actually multiply binomials in your job. That's fine. But you're probably going to need to like organize something or put things together, right? Use math to figure out how much debt you're in. Yep. Okay. All right. So this is going to be our last question for tonight, and it is fractions. Yay. Everyone's favorite. Fractions are your friends. They are. Sometimes frenemies, but they are your friends. Okay. All right, so we've got Boomer says it's A. Let's see. Now this one, when I walk through, I have a feeling that there's going to be a lot of people that did it different ways, which it's going to be fine. As long as you end up at the same answer, whatever way you get there is fine. Okay, so Tala, oh man, Sir Bober, that's a dagger to my heart. Nobody likes fractions. I like fractions. Okay, so Tala, so a cake recipe requires 5/8 of a cup of flour. Okay. Mary and Haloa decide to make the cake together. So Mary has 1/3 cup of flour and Haloa has 1/4 cup of flour. How many more cups of flour do they need to make the cake? Okay, so we need 5/8 total, but we have 1/3 and we have 1/4. So what we want to figure out is how much more do we need to get that 5/8? Okay, so I'm going to first figure out how much flour we have. So we have 1/3 plus 1/4. When we're adding or subtracting fractions, we need to make sure they have a common denominator. So I just go through I call it crisscross applesauce. So we do cross. I'm just multiplying. Applesauce is there. So what we have is we have 7/12 cups of flour. Okay, that's how much we have. So 7/12 of a cup of flour, but we need 5/8. So now what we're going to set up is 5/8 minus 7/12. Okay. So now I'm not going to crisscross applesauce this one because I know that 8 and 12 both go into 24. And I honestly don't feel like working with 8 times 12. That's a really big number. I don't really feel like working with that. So I know that 12 times 2 is 24. So that means that 7 times 2 is 14. 8 times 3 is 24. 5 times 3 is 15. So it's 15 minus 14, which is 1/24. Now, even if you did do cross multiplying, right? 8 times 12, which is 96, right? It should still simplify down to 1/24. So that's how much flour they need. I mean, and I'm not a great baker, but I'd say it's close enough. It's close enough. That's fine. 1/24 of a cup. That's a very small amount of flour. I think it's going to be fine if you just use what you have. Okay. So Shakita, let's see, taking your ACT in October. So I'm here every Thursday at 8 o'clock Eastern. And somebody earlier asked like where I got these questions from. This is just a PDF from the ACT. This is just like a PDF previously released of from ACT questions and things like that. So let's see, there was another question that we didn't do. We could do this one. I like these area puzzles. This one might be kind of hard for you guys to read, but Sydney, what's ACT? Oh, ACT is a standardized test, and that's it's a standardized test that most students in the United States will take for like their college acceptance. It's just it's supposedly designed to show that they're ready for college and that they understand all the material and things like that. Not every college and university requires it, but a lot of them do. So it's a pretty big deal for high school students in the United States that are looking to go to college, right? Now, keep in mind that we have only done like these are really like the first 10-ish questions on this test. So next week we'll come back and we'll do like the next group of 10 or so. Yeah. You know, here's one of the funny things is like and this is exactly what happens with the test thing. Like I just kind of glanced at this question, right? I didn't really look at it. I just kind of, we went on to the scientific method one and all of that because I was like, oh, it's a big diagram. I don't know if I want to get into that. Looking at this diagram now, it is way easier than I thought. They absolutely have all of these numbers in here to trick you. Okay, all they're asking you for, and that's like classic, right? That's classic on any math exam that you look at it at first and you're like, oh my goodness, what is this? This is awful. But then you actually look at it and read the question, you're like, oh, this is super easy actually. So it's just asking you for the area of this rectangle piece right here that's shaded in. So all you really need to know because it's a rectangle, is you multiply the two side lengths together, the base times the height, or the length times the width, however you want to talk about it, right? This side is 21 because that side is 21. Okay, this side is 13.5. The reason, first of all, I've played tennis my whole life, so I know that those rectangles are the same size. But also, I could also look over here and see that this section is 27, and I see that this part here is 13.5, and half of 27 is 13.5, so I know this other piece has to be 13.5 also. Okay, so I just do 21 times 13.5, and I get 283.5, which is, so the nearest, closest to the area, right, is 284. And that's it. They have all the other numbers in there just to trip you up. Okay, because that is part of these exams. That's part of the design of these exams, is to make sure that you really know how to do this work. Okay. Oh my gosh, Sir Bober, that would be bonkers. You would subtract everything except for that. Ugh. I mean, that is a way to do it, but that is not the way that I would recommend doing it. Oof. All right, guys. Thanks for joining me. Make sure you guys follow, click the link, do the stuff, all that good stuff. And have a great evening. Thank you to those of you who just joined. And we will see you next week. Bye.